In this question, a DC to DC converter is given in the figure. The current through the inductor is continuous. The switching frequency is the 500 Hertz. The voltage across the load is assumed to be constant. The voltage across load is the same as the voltage across capacitor. That means it is a 40 volt. The peak to peak inductor current will be. So see, it is a boost converter. So in the boost converter, whatever the current flowing into the inductor, it is the same as the input current or the supply current. So what is the given here? The input supply voltage is given, that is the 20 volt. Output voltage is given, that is the 40 volt. Current is continuous. Switching frequency is a 500 hertz. 500 hertz. L inductor current is continuous. That means it is example of a continuous conduction. Now, the peak inductor current that we have to find out. We have to find out the maximum value of inductor current, the peak value of inductor current. So we all know that the waveform of inductor current will be like this. The inductor current will be changing linearly from I minimum to I maximum. So this is the waveform of inductor current. During turn on time, the inductor current will increase because it stored the energy, and during turn off time it will decrease. If I find out the average inductor current, the average of this value, you will get this average value. So this is the average value of inductor current. This is the average value of inductor current. We can say IL average. Now, this is the maximum value of inductor current, IL max. So the change, the peak to peak ripple in the inductor current is the delta IL. So IL max is nothing but the IL max is nothing but the average value of inductor current, that is the IL. I am taking it as a capital IL, the average value, plus delta IL by 2. So IL average, I am taking it as a capital IL. This is the average value of inductor current. Now, as we know here that the inductor current and the supply current are equal, let's find out first the value of alpha. So in boost converter, the V naught is Vs upon 1 minus alpha. So 1 minus alpha is the 40 upon 20. It's a Vs is the 20, V naught is a 40. That is a 1 upon 2. So alpha is 1 minus 1 by 2. That means it is a 1 by 2 or 0.5. So alpha is a 0.5. Now we know that the input power is equivalent to the output power. Input power is a Vs into Is, average voltage and average current. Output power is a V naught into I naught. Vs we know, the Vs is nothing but 20 into Is, that is the 40, and I naught is nothing but 40 divided by 10. So Is is 8 ampere. 8 ampere. Now we know the IL and Is are the same because the current through the inductor and the supply current is the same. So average value of inductor current is nothing but the 8 ampere. Now let's find out the delta IL. Delta IL is nothing but the alpha Vs upon FL. So alpha is the 0.5, Vs is 20, F is a 500, and the value of L is the 2 millihenry. 2 millihenry. So 0.5, it is also become 0.5 will be cancelled out. So that is the 10 ampere. So the value of IL max is the average value of current and the delta IL by 2. 8 plus 10 by 2, it's a 13 ampere. So value of IL max is nothing but the 13 ampere. So 13 ampere is the right option. It's an NAT question. So the 13 ampere is the right answer. The 13 ampere is the right answer.